All right, so today we're going to be talking about Leetcode 904, fruit into baskets. And this one is pretty cool because I think it will help people with a certain algorithm. I guess I won't spoil it immediately, but I think it will help you drill a certain algorithm and clean up your execution of it, and that's what I'm going to be focusing on. So the problem description is kind of a nightmare in my opinion, but once you decipher this Da Vinci code of fruit and baskets and starting from a certain fruit tree, I think you'll eventually figure out that basically what they're asking is for when you're given an array, they want you to find the largest contiguous subarray that contains no more than two different unique numbers. So like here, you can have 1 and 2, and that's three in a row. But you can't have the whole thing because that would be that would contain three different unique numbers, right? So if you've ever done sliding window, then when you hear like the word contiguous subarray, or you kind of see that concept in the problem, then you know that they're probably looking for a sliding window approach. Now, implementing sliding window can definitely be difficult sometimes if you're not uh, very formulaic and methodical with it. And so I think it can your code can get really ugly if you're not careful, and your implementation could become really hard to follow even for yourself. And once you get lost in your own implementation, that's like a really big problem in an interview. You want to stay like you want to make sure your thinking is clear and systematic, and that's why I think sticking to a formula on problems like these is super important. So let's get straight into the formula. The first part of a sliding window is that you're going to need to initialize the variables of things that you'll need to keep track of within the sliding window. So here I'm going to have an L pointer for the left bound of the window, and then result is going to be the maximum size window that we've found so far, and it's going to be what we're returning, like this 3. And then fruit window is going to be a hash map keeping track of the count of every fruit, that is the occurrences of every fruit in our window. So for example, like this window with 121 would have keys as 1 and the value as 2 because there's 2 1s, and then a key at 2 where the value is 1 because there's 1 2. And then unique fruits is just keeping track of how many unique fruits are in our window. And then the second part of the sliding window formula is you need a for loop for your R pointer. And the reason I do it this way is that you don't really need a while loop because R is just going to increment by 1 each time no matter what. There might be some sliding window problems where the R increments more than once or it moves back, but I haven't encountered many, if I'm being honest, so I'm pretty confident putting this in the formula. So the next part of the formula is adding your first update. So within the for loop, you're going to be basically you've expanded the window by 1 on each iteration in this for loop. So you're going to update all of your values accordingly with what you see in this updated window. So here I have if the fruit we just landed on, that we just expanded the window into, has a count of 0 in the hash map, that means it is a unique fruit because we haven't encountered it before within our window. So we're going to increment unique fruit. And then also we're going to increment the frequency of that fruit we landed on just to update our hash map. Probably slightly the most difficult part of the formula is that you need to check whether the window you've expanded into is valid or not. So basically you want to check if it's not valid, you're going to perform iterations until it is. And you can do that with a while loop. So basically, while the window is not valid, we're going to make some changes until the window is valid. So here, we're going to say that while L is less than R, because we never want L to cross R, and while unique fruits is greater than 2, this is a problem because it causes this. If unique fruits is greater than 2, then it's an invalid window, right? So here, basically we're preparing to increment L by 1, which shrinks the window, right? So if we go over to the examples, if we start with 0 and then 1, and then we expand our window to 2, we will realize that we have 3 unique fruits, right? So we have to shrink the window now to just 1, 2. And we can do that by incrementing our L pointer, which was still over here at 0. So we increment our L pointer and update things accordingly, our hash map and our unique fruits count. We're going to update those accordingly based on that move. So it's just like a moving system of making sure we're updating all of the variables we have and maps that we have so that everything is tracked accordingly. And then what's great about this system is that once you've done this while loop to fix, quote unquote, fix any invalid windows, now you can be completely sure that the window you're on after this while loop is valid, and then we can just do a max check of is the window we're on the largest window we've seen, or is it not? And then that's pretty much it. So then we can just return res and just run the code and make sure it works. And there we go, it's accepted. And submit it. And it works pretty well. Overall, I think what's interesting about seeing it in this formulaic way is it actually makes it pretty easy for your brain to process the entire thing at once. So I'll add some editing here where you can see kind of the sections of code and what each section does. And then that is kind of the blueprint for how you want to attack like any sliding window problem. And I recommend looking at another sliding window problem and trying to use that same formula. And it's pretty surprising that you can um, use the same formula over and over again. And it allows you to think pretty clearly and cleanly. And as I say, like slow is smooth and smooth is fast. So if you want to solve problems quickly, this is how like the best competitive programmers and interviewers attack problems, is that they're able to um, use formulas and systems of thinking to attack problems. And yeah, I think this is kind of the next level of interviewing, where it's not just that you can solve the problem after like an hour and a half of thinking and struggling with your code. It's about being able to have a formula for approaching the problem type and the concept that you identified and implementing it quickly. And I think that will set you apart from a lot of people.